Today's lesson is 8.4, Logarithmic Equations. Let's go over some of our vocabulary for this unit. A common logarithm is the logarithm with base 10. This is the log where you see just the word log. A logarithm is the inverse operation to an exponential. We saw in the last units that to get rid of the exponent, x in our exponent, we could take the log or the natural log of both sides. And of course, our natural base is our logarithm with base e, and we commonly see that as ln, the natural log, versus log of log base e. This is not very common, but it is true. So today we're going to solve logarithmic equations, and a logarithmic equation has a variable within the log. To solve a logarithmic equation, you need to use the inverse property, and here's my inverse property right here. Because logarithms are inverses to exponentials, exponentials are also inverses to logarithms. That's how inverses work. And so to get rid of this log that I have right here, I'm going to raise it to the base. I'm going to make it an exponent. I'm going to make my log become my exponent. Notice that the base that I choose is the base that the log has. And when I do that to the side with the log, I get whatever's here as my answer because the base and the log with my common base, they cancel each other out, leaving me just whatever's left, my log base of whatever. That's what x is. Now, there are some logarithmic properties to keep in mind. The product rule, the quotient rule, we've done the power rule, we've seen the change of base rule, and there is the equality rule that says if you do have the two logs with the same base, then their two of parts need to be equal as well. Let's go ahead and let's take a look at our first equation. So we need to solve log base 2 of x plus 5 equals 9. We're going to go ahead and use the inverse property, and we are going to first focus on the base of our log. So we want to make sure that we know what the base of our log is. That would be the 2 right here. So what we're going to do is we're going to raise each side of our equation to the base of 2. Okay, because this is what the inverse property says. Okay, now what I do to one side, I must do to the other. So there we go. Now, that inverse property that we just saw says that this 2, this base of 2, is going to undo this base of 2 with its log that goes along with its log, and they're just going to cancel each other out, leaving me with this part, which is equal to this number. I can go ahead and put this into a calculator, and it will tell me what 2 to the 9th power is. So remember, we are solving for x. Let me make it purple to remind myself that I'm solving for it. But basically what happens is the log and the big blue base 2 are going to cancel each other out, and I have x plus 5 left. Whatever was inside that parentheses. 2 to the 9th power is 512. Okay, so 2 times 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 2. 2 to the 9th power. And then I just simply have to finish solving this equation by subtracting 5 from both sides. And I get 507. That was it. Let's take a look at another problem, because of course they're not going to stay this simple. Now this also works for our natural log, so take a look at this question. Not much difference. The only difference is I see a natural log versus a log. But I also see that this log right here, this natural log, it is not alone. It has the 3 hanging out in front of it, and it has the minus 5 hanging out behind it. So I need to get my natural log alone so that I can solve this problem. So the first thing I need to do is I'm going to add the 5. I'm going to bring down my 3 natural log of negative x. I'm just going to go ahead and copy it. And of course, 10 plus 5 is 15. I'm going to remind myself that I want to get that x alone. Now, the closest I can do to getting it alone right now is to get it in ln parentheses negative x. That's the closest I can do. I'm going to go ahead and multiply. I'm going to go ahead and focus on the multiplication. So to get rid of that 3, I'm going to divide both sides by 3, leaving me the natural log of x equals 5. All right, now I'm thinking I need to use that rule to get rid of the natural log. So I need to know what the base of the natural log is. I need to remember. Well, don't forget the base of ln is e. The base of the natural log is e. So I'm going to go ahead and I'm going to raise each side to the e power. So I'm going to say e to the natural log of negative x equals e to the 5th power. Okay, so what's going to happen over here is the e and the natural log are going to cancel each other out. And I am left with negative x equals e to the 5th power. My x is not completely alone. There is an invisible -1 hanging out in front of that x. So I have to get rid of this -1 by dividing by -1. So I'm going to go ahead and grab my calculator and I'm going to put e to the 5th power divided by -1, or negative e to the 5th power. Either one would work. And I get 1.48.4131. And if we were to round, oh, let's say they wanted us to round to the nearest hundredth. Remember, 100 looks like this. Its decimal would be right here, and we need 2 numbers, and the third number is going to tell me if I should round or not. So here is my decimal, 1, 2, oop, no, 2, there we go, the 1, and the 3 is going to tell me, and I didn't need the 1. So the number underneath the arrow is 4 or less, so I'm going to go ahead and let my underlined number rest, and I'm going to put my answer as negative 148.41. Whew. All right, let's try one last one. Now this one looks very, very complicated. It looks like, ooh, there's 2 logs. The nice thing is they both have the same base. Notice that they both have the same base. I can't go to my calculator. I know a lot of you are thinking, oh, let's just go to the calculator. I can't because I have the x, okay? And I can't put that in and see. So I'm going to go ahead and use the product property from the first slide, which says that when we are adding them, I can take this and multiply them. That's what the product property says. So I'm going to go ahead and change it to log, comma, 5x times x minus 1. You know what? I'm going to make these more brackets because all that parentheses. There we go. I am going to go ahead and distribute the 5x. Okay, so I'm going to do 5 times x and 5 times -1. So 5x times x would be 5x squared, and 5x times 1 would be 5x. Okay, now I think I have it down to where I think I can go ahead and use the inverse property to go ahead and solve this problem. Now the base of my log is 10, so I'm going to raise both sides to the 10th power. There we go. Equals. And this side will be 10 to the second power because when I'm solving an equation, what I do to one side, I have to do to the other. Now I want to go ahead and get these x's alone, and there's two of them this time. Remember that this base here is 10, so this logarithm and this 10 are going to undo each other, and I'm going to end up with 5x squared minus 5x equals 10 times 10, 10 squared, 100. All right. Now, the really nice thing would have been if I would have had an x or an x squared, preferably an x squared, on the other side where the 100 is, but I don't. So that means I'm going to have to factor. I'm going to go ahead and bring my 100 over here, and I'm going to put them all together on the same side. Now, as I'm copying this, I'm thinking to myself, there is a number that goes into 5, and 100, and that number is 5. So I'm going to go ahead and I'm going to divide both of these. I guess I should be highlighting the square, huh? There we go. I'm going to go ahead and divide this by 5. So if I divide everybody by 5, I end up with x squared minus x minus 20. Let me make sure I have all my minuses correct. Okay, I'm good. All right, now the 5 I can simply ignore because of course 5 is never going to equal 0. So I'm going to take the stuff inside the parentheses, the x squared minus x minus 20, and I'm going to factor it. So I'm going to come over here, let me change my color a little bit, and I'm going to factor x squared minus x minus 20. And I'm going to go ahead and I'm going to factor it. I have to do this to solve. So remember I showed you that little trick where you're going to take your x value, you're going to look at your x value, and you're going to say x squared is x times x. And then you're going to look at your 20, let me color it in purple, and you're going to say to yourself, well, 20 can be 1 times 20, or 2 times 10, or 4 times 5. Now, 4 times 5 is the most common factors of 20 that we use when we factor, so that's the one I'm going to try first. Now it is negative, so that means that one of them must be negative. And so it's either going to be plus times minus, or it's going to be minus times plus. Okay, and I'm going to figure out which one it is after I do my cross multiply. So x times 4x would be 4x, and x times 5 would be 5x. Can I make that be negative 1x from here in the middle? I think I can, if this one is negative and that one is positive. If I put positive 4 minus 5 into a calculator, I do get negative 1. So this is positive and this is minus, and my factors would be x plus 4, x minus 5. All right, let's go back and put that into our problem. And now I have to go back. Remember, I technically I have the 5 there, but it's not really going to be part of my solution. I have two answers. I have an answer here and I have an answer here because I know that 5 does not equal 0. So I've already ruled this 5 out. So I'm going to use the zero product property, and I'm going to say x plus 4 equals 0. If I were to solve this equation, I would subtract 4 from both sides, and I would get x equals negative 4. And then I would set my other parenthesis, my other factor, equal to 0. I would add 5 to both sides, and I would get x equals 5 as my other solution. You might think, yay, we're done. But no, you have to go back and you have to check. So we're going to go all the way back to this equation right here. And the nice thing is it is base 10, so we can go ahead and use our calculator. We want to see, do we get 2? So when I use negative 4, do I get 2 for an answer? When I use positive 5, do I get 2 for an answer? Let's hope that my Desmos is down here. Oh, no, it's not. All right, here we go. Let's go to Desmos. Let me clear that out. All right, I can go back and now I should be able to split my screen. Here we go. Yeah, all right. All right, ladies and gentlemen, here's what I'm going to do. I am going to grab this answer here for x, and I'm going to plug it in for the x's right here into my calculator. So I'm going to go ahead and I'm going to say log of 5 times -4, close it up, plus function log -4 minus 1. Nope, 4 minus 1. It says undefined. It doesn't say 2. I don't think I put it in wrong. I really don't. Well, okay, maybe I'm thinking I put it in wrong. So let's do this. Well, let's put it in this way. 5 times -4 would be -20. There we go. Plus log -4 minus 1 would be -5. I get undefined again. Why? Because you cannot take the log of a negative number. I can do log of 20, but I cannot do log of -20. I can do log of 5, but I can't do log of -5. So this is not an answer. Remember, in the past, we have called this like an extraneous solution, but this is not an answer. Let's go ahead and see. I'm going to clear all of this. Let's go ahead and see if 5 is an answer, because it could happen that it's not, and then I have no solution. So let's go back. Log 5 times 5 plus, remember, I'm looking for my answer to be 2. 5 minus 1. And look, I got 2. There's my solution. I checked it in the calculator.